per unit time. So in the top, in the first event example that I gave you, number of wrong calls in an hour, M per unit time. What's the M?
The number of wrong calls.
Number of wrong calls. In the second, number of
Hours.
accidents, right? In the second example.
Mm-hmm.
Third example, M is
Number of flaws.
number of flaws. And fourth example,
Number of bacteria.
number of bacteria. So if we have M is the rate is M per unit time, we define the Poisson probability distribution as probability that X is equal to X is e to the negative M times M to the X over X factorial. Again, it's an exponential function. The mean of a Poisson distribution is just M, and the variance is also M. Now, if we had time, I could prove those things to you, which would be so cool if you're into math, but we don't have time. So example 1. Cars have been observed to pass a given point on a back road at a rate of 0.5 cars per hour. A rate of 0.5 cars per hour. Find the probability that no cars pass this point in a 2-hour period. All right, so what is our M?
0.5 cars per hour.
0.5 cars, well, 0.5,
Mm-hmm.
right? And X is the number of cars that pass the given point in a 2-hour period. So the probability that X is X is going to be, wait a second here. 2-hour period. So the X that I'm looking for is, hold on just a second. Okay, rate is 0.5 cars per hour. Find the probability that no cars pass this point in a 2-hour period. So the M isn't actually 0.5. The M is 0.5 times 2. Right? Because it's 0.5 per hour, but I'm looking at a 2-hour period.
Our rating M is just the letter M.
Yes. All right, and so my M is 1. So the probability that X is 1 then is going to be e to the negative 1 times 1 to the X over X factorial. Probability that X is going to be e to the negative 1 times 1 over X factorial. And I want to find the probability that X is 0. So I get e to the negative 1 over 0 factorial, which is actually 1, and that's 0.358. Question, Grant?
No. I thought this was the formula, and I was thinking, why would we use 1 to the anything?
Well, in this
Yeah,
case,
it's
it's
this
1,
function.
but it's m to the x, right?
Sorry.
E to the negative m to the x. So the idea is, basically I have to figure out what that m is, and then I've got to plug it into the formula, find the probability that x is 2, I plug in a 2 for the x or whatever. All right, example 2, faults occur on a piece of string at an average rate of 1 every 3 meters. 1 every 3 meters. And the letter that they used for that is actually lambda. Okay, it's not my m yet. I got to figure out what my m is. But they use lambda, but you don't have to know that. Okay, just one every 3 meters. Bobbins each contain 5 meters of string. Each containing 5 meters of string are to be used. You know what a bobbin is? It's like a little, yeah, where you get thread like a spool they call it.
Yeah.
All right. So bobbins each containing 5 meters of string are to be used. What is the probability that a random selected bobbin will contain A, 2 faults, and B, at least 2 faults? So my M is going to be what?
5/3.
5/3, because it's going to be 1/3, 1 of every 3 meters, times 5 meters, right? Because that's my interval. So my M is 5/3. And I think I have the answer on there, right? So the probability that x is 2 is e to the negative 5/3 times 5/3 to the second over 2 factorial. You get 0.262. Probability that x is greater than or equal to is 1 minus the probability that x is less than 2, which means it's either 0 or 1. Do you notice that we're using discrete probability? So when I say probability that x is less than 2, there are only 2 integer values that are less than 2, right? And so I find that probability and I get 0.496. Now this is the way you do it on the calculator. Take your calculator out. And almost all of these questions are for Poisson distributions are calculator active questions. When you're doing your homework, can you start making sure that you're using your formula sheet? You all have a formula sheet at home, right, or in your binder?
It's on your,
Just so that you know what you have to memorize and what you don't.
is it on your learning plan?
I believe so, yes. Okay, so to find the probability that x is 2, we go to second distribution, second stat, and we look for Poisson PDF. It's option B, I think. The notation is you go Poisson PDF, your m comma x. So our m is 5/3. Comma, we want the probability that there are 2 faults per bottom. And hopefully you get 0.262. Yeah? Okay. The next one, to find the probability that x is greater than or equal to 2, we're going to go 1 minus second distribution, Poisson CDF, and type in 5/3 comma 1 because we're less than or equal to 1. And you should get 0.496.
Is it no less than or equal to 2?
It's less than 2. We want less than 2, so basically it's less than or equal to 1. Right? What integers are less than, strictly less than 2? Originally, we wanted the probability that x is greater than or equal to 2. So that's 1 minus the probability that x is less than 2. Yes?
Yeah.
Okay. Are we good? Did you get 0.496?
Yes.
All right. Poisson homework. There's Poisson homework and then there's the Poisson assignment. Let's see how far we can get through the homework. There's only 2 questions here. So number 1, the random variable x is Poisson distributed with mean mu and satisfies that the probability that x is equal to 3 is the probability, no?
No.
Your
Car
page?
accident. Right.
This page?
No.
No? Okay, you just go right to the assignment?
Yeah.
Mhm.
Is the first assignment the number of car accidents
Yes.
occurring per day? All right, well, let's do that then. Let's start this. Number of car accidents occurring per day on a highway follows a Poisson distribution with mean 1.5. Find the probability that more than 2 accidents will occur on a given Monday. So what I want to write is, find the probability that more than 2, x is greater than 2, will occur on a given Monday. All right. So let x be the number of accidents which occur in a day, right? Well, they're giving us the mean, actually. They're giving us the m. So that's easy. So how am I going to figure this out? Probability that x is greater than 2 is going to be what?
1 minus Poisson CDF.
Minus P2.
1 minus probability that x is
Less, greater than 2.
less than 2 or less than equal to 1, correct?
Since it's greater than 2, doesn't have
Well,
to
it's
be less
greater
than
than 2
2.
includes 2.
Oh, yes, greater than or equal to 2. Just kidding. Okay. All right, and what did I say on that calculator stuff? Is it gonna be less than or equal to or not? Okay,
It's the answer for 1.11, well, 0.191.
I'm not gonna, if you use the calculator, and you go 1 minus and then use the calculator, you're gonna only get 1 minus the probability that x is less than 2, because it's a strict inequality. Right?
Well, what is the answer, 0.191?
Yes, the answer is
So
0.191.
you use 1 minus Poisson CDF, 1.5 comma 2.
And it works?
Yeah.
Because on the last one you did 1 and it just included 1 and 0.
Oh, yes, yes, yes. Okay. All right. So please note that on your calculator it's going to be, and it's the same for binomial, isn't it? Less than or equal to?
Mhm.
Okay. So calculator, Poisson PDF is okay. I mean CDF. CDF is okay. So if it said, if I had less than 3, let's say it said less than 3, I could use my calculator and just go less than or equal to 2. Correct? Okay. We understand that?
Yeah.
Because I'm only dealing with integer values. Okay. All right, B is given at least one accident occurs on another day. Find the probability that more than 2 accidents occur on that day. So I want to find the probability that more than 2 accidents occur. X is greater than 2 given that X is at least 1. Greater than or equal to 1. Okay. But let's think about this. Probability that X is greater than 2, given that it's greater than or equal to 1. So isn't that just going to be the probability that X is greater than 2?
No, because given that, because it could be, you have to take away that there's not any accidents.
Okay, I have to take away that there's not any accidents. So how about this? It would be 1 minus the probability that there are no accidents.
Mm.
Right?
But
Because this is
Also-
going to be 1 or 2 or whatever. So it's like Grant said, I can just make it 1 minus the probability that there are no accidents.
But you also have to take away 1 because you want greater than 2.
No, because I'm given
for
that
the
it's greater
given.
than or equal to 1.
Yeah, but you also, but to find the probability, you need X is greater than 2. So you,
No, what I'm saying is that this means the same as that.
yeah.
I'm given that it's greater than or equal to 1, so that's like my denominator, right? So 1, 2, 3, 4, whatever is my denominator. But I have to say, all right, well, that's going to be, it could have been no accidents, and I have to subtract that from the probability. So this is like, given that it's greater than, what's the probability that it's greater than 2? 2, 3, 4, 5, dot, dot, dot. And this is given that it's greater than or equal to 1, which is 1, 2, 3, dot, dot, dot. So the only one I have left is that 0. Does that make sense?
Mm-hmm.
Okay. You don't have to do it that way. You could do it using the conditional probability. And X is greater than or equal to 1 over the probability that X is greater than or equal to 1. Okay, you could do that. You should get 0.776.
Yeah.
Yeah?
So what would we,
All right, I think, no?
I just think that gives you, if you do 1 minus the probability of x equals 0, you're just finding the probability that x is 1 through greater.
Which is
But-
what you're given.
Yeah, but you also want to find where the probability of x is greater than 2. So you can't include 1 or 2 either.
Well,
Oh, you're right. So
So
that
that's-
becomes our denominator.
Yeah,
You're right. So this is, what did I say it was, 0.776? Okay, that's our denominator, and now we have to put probability that x is greater than 2 over that,
okay.
right? Okay, so your answer actually should be 0.246. All right, just finish that assignment. There's just 2 problems, right?